Hello everyone. Today I'm going to explain about my Mlops Capstone project. Here in this project, I have used three different set of data set to create three different models. So the first one is the hotel data set, which is consisting of hotel name, place, days, user code, travel code, and the hotel price and the number of days they have, like the hotel was occupied, and the date also. And the second data set is basically the flight data set. It is all about the information of different flights and their class, flight type, price, and the distance of the flight has been traveled, agency, and the dates. And last data set is users. So users data set is nothing but all about the information of different users and their company name and the gender and the age. So these three data set I've used to create three different models. So let's see those things. So before that, basically here in this project I have created three different model, and after creating those models I have containerized it by using Docker container, and also to expose our model through RESTful API. I have used Flask, and also I have used the Streamlit apps to expose our model into the web services. So for the scalability and load balancing part, I have used Kubernetes, and to monitor the performance and track the issues, I have used MLflow library. That is very easy to use, and that is for very useful. And for the version control, I've used Git, so that we can we can have information regarding the changes of the code. And if any issue persists, then we can change the version of the code. We can come back to the previous version of the code. So without wasting time, let's see the codes that I have used to build the application, build the model. So first of all, this is the gender classification model. So the first step is to importing different types of libraries and import the data set. And this is the data set first view, and these are all the first five row in the data set. And I've done the pre-processing. So this pre-processing step is like same for all the thing. Let's see for the first model, let's see the pre-processing part. Then after that we can skip this part, as this is common for all the things. So the first thing is we have to check for the null values, also check for the duplicated values. We have to check the the column types, so that we can do the data pre-processing in a good way. And after data pre-processing only, we can have see the features the features which are all can give the best prediction. So we can choose the features before building the model. And I've done some analysis also, univariate analysis, bivariate analysis, and multivariate analysis as well. And after that, after all those things, I have separated two things, like train and test. I have by my data set I have divided into train and test. So my test data set I have used for the testing the model, how it is performing. So the baseline model I've chosen is logistic regression. So logistic regression, and this simple imputer function I have used to impute the missing values, and the strategy I have used as median. So this is the baseline model. By using baseline model, I got the accuracy nearly about 98%. So this is the training accuracy, and this is the validation accuracy. And I have used the logic of if the trains accuracy is greater than validation accuracy, then we can say the model is overfitting. So in this case, the training accuracy is not greater than the validation accuracy, so model is not overfitting in this case. So I've tried with different models like decision tree classifier and also the random forest classifiers. So by using decision tree classifiers, we got the training accuracy I got nearly about 1. So this is the clear case of overfitting. The validation accuracy is 96%. So train accuracy is greater than the validation accuracy. So this is the clear case of overfitting. So, and also I have tried with gradient boosting classifier. By using gradient boosting classifier, I got nearly about training accuracy as 1 and validation accuracy as 98. So this is also case of overfitting. Tried with XGBoost also, the same kind of result I received. So as a as a as a benchmark model, I have chosen logistic regression. This is the last model. So as we have chosen logistic regression as the final model, so we have to to use this for in the further stages. We have to dump it in the pickle Python file. So this is the step that I've dumped the code of the logistic regression into the pickle file. I have built another model for the travel price prediction system by using flight dataset. So this is it. Here we can see the first step is to importing different libraries, the required libraries, and also the dataset and the data mining, exploration, and data preprocessing steps are similar only. So let's not waste that much time in those simple steps. We are moving forward to the main model building part. So in this case, in this travel price prediction system, as a baseline model, I have chosen linear regression. So in this model, basically, I have tried with baseline model as well as the hyperparameter tuned model. So in the very first, I have used the basic linear regression model, and by using the basic linear regression model, I got the accuracy near about 64%. And this is the hyperparameter tuned model. So hyper after tuned, I got the accuracy nearly about same. So I've tried with lasso and ridge also. So by using lasso regression baseline model, I got the accuracy nearly about 64.3%. Little bit improvement I saw after applying this lasso model. And so I've tried with the hyperparameter tuned lasso model also. So the accuracy is more or less same only, just 0.1% difference maybe. So by using Ridge baseline model gave us the accuracy, same accuracy like the lasso model, and hyperparameter tuned Ridge model is giving the same accuracy as the baseline model. So let's try with I've tried with decision tree regressor also. So by using decision tree regressor, I got the accuracy of 1. This is the clear case of overfitting because this model is trying to memorize the data without generalizing the patterns. So this is not good for our production. So we can ignore this model. So this is the decision tree tune model, that is 99.66% R2 score we are getting. So this is not a good performance because it's overfitted in the data. So let's try with let's see the random forest performance. So this is the random forest baseline model. It is also memorizing the data. It is a clear case of overfitting. Let's see the tuned model, tuned version of it. So tuned version is it's generalizing in a better way as compared to other models. You can see we are getting performance, like we getting the R2 score as 86.4%, and the MAC is also less. MA is also nearly about less than 10, and MAC also nearly about 2. So this can be the good model. So as a benchmark model, we can choose this random forest tune model. So same like previous, we have to dump it by using pickle or job leave. So we have used pickle to dump it, so that we can use the model in further cases. So let's see that Mlops part. So this is the gender classification model, and I have first of all, I have added all the pickle file into one folder to import whenever it's required in our code. So this is the app.py, where I have written the Flask code as well as the basic preprocessing steps, and and also imported the our scalar model and the logistic model, so that we can use it. So this is the Docker file, and in the Docker file, basically we have copied the requirement.txt and the model as well as the scalar and the PCA pickle files, so that we can containerize it into in a like Docker basically help us to bundle all the codes and the dependencies in a container, so that app can run like the different types of model can run in different containers, so that it will be easy, for production ready environment. And this is the Flux code, uh, like to expose our model in the production, expose our model into the server. We have used the Flux, so this is the Flux code. So let's see the web page by using Flux that we have generated. So this is the gender classification model. This is the streamlit version of the gender classification model. So we have chosen 5 user ID and the company name is Wonka Company. And let's change the Wonka Company to Acme Factory, and let's see how the app is predicting, how the model is predicting the gender. So it's taking bit time. Let's wait for it. Okay, now predict. So based on the input, it is predicting the gender is female. So this is the model. So I forgot to show you the Streamlit version of this app. This is the Streamlit version of the app. We can check. We can also see the Flux version of the app. So if we want to see the Flask version of it, we have to run the Docker. Whatever we have pushed the code by using Docker run, we can see the Flux code of it. So for the Streamlit app.py, I've used the Streamlit run command to see the Streamlit app into our server. So this is the Docker code. You can see this is the Docker code. So we have exposed our app into the 8000 port. So it is referring to the 8000 port in the server, and this requirement.txt. In this requirement.txt, we should write all the dependencies. Those are required for our product, our model. So these are all the requirements that I have like mentioned. The version of all the dependencies also necessary to write. So let's see the other models as well. So this is the Airflow version. Let's see the uh, travel ML system. This is a travel ML system. This is basically a travel price prediction system. So this is the app.py, the same like the gender classification model. We have used the pickle that model we have generated and converted into the pickle format. So the pre-processing step we have to mention as we've done into the collab file. So this is the Flux version of it. We have written the Flask code to see the model performance in the web service or like web page. And also I have exposed to the 8000 port, the same like as gender classification model. And also here also we have used Docker to containerize it. And here in this case I have used Kubernetes to like for the scalability and load balancing part. I have used Kubernetes. So by using Kubernetes, we can easily balance the load, and also it can be scalable, because Kubernetes can help manage the deployment multiple instances of our model to handle varying level of traffic. And for the CI/CD purposes, I have used Jenkins. Like Jenkins, the step was a bit different. Like before using Jenkins, we have to push the code into the GitHub, and by using GitHub, we need to connect the Jenkins with our model, so that if any changes happened into the code, we can have a track of it. And also we can see we can deploy like continuous integration and continuous deployment can be in the fields. So and git we have used to so for the version control to keep track of the changes of the code. And we have used MLflow to see the performance, like the monitor the performance and all. So let's see the MLflow dashboard. Yeah, this is the MLflow dashboard we have used for our model. Let's see the model matrices, how it is showing model matrices. I have to run it. It's not showing. Let's see. This one maybe. This one is the model matrices. So all the model matrices it will show in the dashboard. So it can help us to track the performance of the model. So this ML flow is based on it's created by Databricks. So it's a great innovation, I would say. So this is the email flow code. Let me show you. This is the this is the email flow code. Like this, we have to write it, and to see it into the to see it into the server, we need to use this ML flow server host. I have used a port 5000 to to show it. So this is the code to open the ML flow server. Also, beside it, in addition of it, we have used the Airflow server to automate the things. So, like by using Docker only, I have used the Airflow. So this is the DAG code that I have used. So this can help into the automation. So by using DAGs, you can see here I've written the code so that the first of all, the this is the load data tags code. I have automated using the DAGs, and this is the transform data tags, and this is the random forest tags. So this is the dependencies, the tags dependencies. So the first load data tags will come into the picture. After that, transform data tags will run, and after that random forest, like after transforming the data, the model will build. So that is the process, so that I have written through DAGs. So for this to like for this for running this DAG, I have used Docker actually. We can use as like cloud as well to run the Docker. So and let's see the let's see the Flux version of this travel price prediction system. This is what we have exposed. This is the Flux code that I've written. This is the web page that I've written for Flux price prediction system. This is the like boarding city we have to choose. Let's choose the boarding city as Campo Grande, and destination city is Natal, and the flight type, let's choose it as first class, and selecting agency Cloud5. Let's predict the price for the flight. So it's running. Let's wait for it. So it is taking too much time. So like this, it should show. Maybe the issue is with the Docker. That's why it's taking too much time. The prediction, like it will show like this. The predicted price is 996.92. Let's see the third model that I built. That is basically hotel recommender system. So in this case, I have used the collaborative filtering. So collaborative filtering basically it suggests hotels based on the user preferences with similar interest. So here I have developed the Streamlit app. So this is the code for the Streamlit app. Um, these are all the I have imported the hotel DF data set, and I have used the label encoder to label the data, like label encoder to label the data. Also divided into the train test and use the UI by using Streamlit. So these are all the things like I have used the set page configuration. You added the title and markdown, also added the sidebar header. So let's see the application, or let's see the Streamlit application. How is it looking? So this is the application. This is the application. We have to choose the user code. So based we are choosing 6, and based on this user code, it will like collaborate by using collaborate filtering. It will show the recommended hotels. So these are all the recommended hotels that is like that is recommending by the model: Hotel A, Hotel BD, Hotel AF, and Hotel CB, Hotel AU. So these are the hotels for the user. So so that's all about my ML my MLOps Capstone project. Thank you.